Welcome everybody to the 2015 Michigan Building Code, International Fire Code on marijuana grow operations, consistent standards for approvals and inspections. Some of the items we're going to cover today under that broad category are processing. One of my favorites is administrative tools, learning how to identify hazardous material areas. And we're going to focus and narrow in on a specific hazard identification called CO2 applications. And we're going to do that because CO2 applications is a relatively simple, narrow scoped hazard. I don't want to get into a lot of detail, at least at first, on identifying complex hazards and multiple types of hazards. I want to focus on that hazard and how to deal with that hazard, and then we'll build upon that. Hopefully that is a good strategy for us. So currently Michigan is on the 2015 series of I-codes. Michigan has amended the building code, the mechanical code. The International Fire Code stands alone as is. And NFPA 1 2018 is brought in by the marijuana rules and the marijuana law. Typically, we would not be dealing with NFPA 1 in our typical construction in Michigan. We're going to look at some of the marijuana rules specifically, and NFPA 72 briefly, and just touch on what's in NFPA 55 a little bit. And we'll bounce back and forth between a couple videos, short video clips, and maybe a couple documents if we have time to show you what those documents that I have prepared as handouts that we will make available after the presentation. They should be available on the website shortly thereafter. A little bit about myself. Kendall Nightlinger, a fire protection and mechanical inspector. Been an inspector since 1992. Also a lifetime state of Michigan code instructor, number 1952. And I want to make something clear here. I'm not, we're not here to judge anybody, not here to tell anybody exactly how to do things. We're here to share information, share my experiences, my interpretations, and promote a sharing of information amongst the participants. Today's participants is a very small group. Right now we have Neil, a very knowledgeable inspector in the state of Michigan, one of the top inspectors that we have here. I'm glad that he could join us today. There may be a couple others that join us a little later on. But we're encouraging them to share their personal experiences with the group as well. So sometimes I get a little animated, especially once I get into certain topics. And excuse me if it sounds like I'm preaching. I'm not really preaching and telling people what to do. I'm just passionate about the subject matter. And basically passionate about the day the light bulb came on in my head about my true mandate, our true mandates. Quite often, so I've been doing this so many years, and I would say my first 10 years as an inspector, I was still definitely a novice. Sounds like a long time, but it was probably about 10 years before that light bulb came on in my mind, is that, hey, it's not really up to me. It's the code is there for a reason. The code, you know, I didn't write the code in that case. There's certain things that are definitely mandatory. We can't just arbitrarily set the code requirements aside, is one of the most important things to remember. We can allow equivalence, but it is up to the designer and the permit holder to propose an equivalent and then demonstrate that equivalency. We cannot merely just set the code provisions aside, just because it's uncomfortable or the easy way to get through the situation. So this leads into one of my favorite quotes. It's by Theodore Hesburgh, former president of the University of Notre Dame. Starts out by, my basic principle is that you do not make decisions because they are easy. You don't make them because they are cheap. You don't make them because they're popular. You make them because they are right. So I keep this over my desk as a reminder during those difficult moments when you get challenged and things, occasionally somebody tries to put some political pressure on you. It's just a reminder of why we're here. A little inspiration for today, especially as code officials and as designers, design professionals alike. I teach courses to a lot of different types of groups, and I expect some design professionals to log on to here and also participate in this course once we've posted it. So your smile is your logo, your personality is your business card, how you leave others feeling after having an experience with them become your trademark. It's just taking that extra 5 minutes with somebody to hopefully make them feel a little more at ease, a little more comfortable, that you're not just in the business of handing out bad news, that you're there to help them through the process. You're not there to design it for them, but so to speak, we're not there to leave them standing out in the cold. At least give them some direction of where to go for resources, where to possibly look for solutions. You know, obviously we're not in the business of making recommendations for individual firms or anything of that nature, but one of my favorites is to say, make a statement to say, well, people have done this in the past and it's been, you know, approved by certain jurisdictions, and certain jurisdictions have not approved it. So an important note for today's class, again, not all the items herein are strictly related to marijuana grow operations. I have included those for discussions and illustrative purposes only. The key takeaways here: identification of hazards and where to find answers. Another important note, the PowerPoint is not meant to provide all the class content. It is key for talking points only. Class participation is key. Additional commentary and videos and so forth that we will add in along the way is also key to getting these points across. Again, my format's a little bit different than some. We nickname them war stories. Let's share war stories if we have them. And lively discussion so that we can hear what others are experiencing and how they are solving problems. And I know that Neil's an expert at solving, you know, helping people solve problems or solving problems on his end as far as how to look at a project objectively, make decisions in a non-arbitrary fashion. So I like to start off when we get in a technical part of this with tools. So you'll notice part of how I set up my presentations is you'll see bold, where bold is of moderate importance. The red bold will be keywords. So I teach a lot with keyword strategy. I also use those in my license prep courses when I teach those on test taking techniques, but they help us solve our everyday problems. So the keyword here is tools. One of the most important, but not the most important portion of those toolkit is the scope of the code. We have to make sure we remain within the scope of the codes. Today we're going to focus on use and occupancy primarily on those, under the scope. And here's some examples of use and occupancy. Yes, this is not marijuana grow operations per se, although the lab on the left, they do a lot of quality control testing. They are required to by state mandates. As part of the marijuana regulations, there are labs in these places where they test the purity. They also test the material for contaminants. They definitely do not want chemical contaminants or biological contaminants contained in the cannabis products. I'm going to back up though. So when we talk about use and occupancy, companies are continually changing the way we use buildings, the way we build them, and the way we use chemicals and materials within them. And here's the thing about that we learned back in high school, that scientific experiments change one variable at a time. Unfortunately, in the construction world, we're most often changing multiple variables at one time. So if we're changing one particular project, we're changing the way we use the building, we're changing the way we construct it. There's always new methods and materials that are coming out. And there's also new chemicals that are coming out, and new chemical processes, and new materials that we're manufacturing. So when we change more than one variable at a time, unfortunately, we have unintended consequences. And that's the reason why we are going to veer off into an area that's foreign to a lot of people, and that is the performance code language today that you'll see really under the intent of the code. Here's just one example of use and occupancy, one example of change. Most of you are probably familiar, unless you're forbidden to walk into a beer joint or a pub or a lounge. You'll see that seems to be a lot of these places are in a competition to see how many taps they can have on display and functional. So there's many of these locations now that have over 100 beers on tap. There's a place in Chicago that I'm aware of that had 100 beers on tap per floor over 3 floors. So total they had over 300 different beers on tap. So that's what you see on the front. Looks pretty cool, right? Unfortunately, this is what we see behind the scenes. Literally miles of tubing, cluttered aisleways. Up in the upper right corner, you can see these black items along the upper right. Those are diaphragm pumps that run on CO2 gas. Unfortunately, the majority of these are piped to vent that CO2 gas that runs that pump into those spaces. We'll talk more about that later. Use and occupancy, another example of change. A lot of our industrial parks saw a lot of high vacancy rates around 2008 to 2011-12. They're starting to fill back up due to economy expansion. A lot of those look like this on the outside, just like they used to, but here's what we have on the inside. Typically, a lot of these industrial parks have went to a high percentage of cannabis indoor cultivation, or grow, as we like to call it. Anything from novices, amateurs, to professionals to pharmaceutical companies becoming involved. Big business. So all different levels of professionalism in the operation and design of these places. They do fall under the same regulations though. Here's another view of grow operation. Obviously their lights are on at this point. Small plants sitting on the floor. On the right, what we have is very common in these places, that gray circular fan in the upper right corner underneath the item in blue there is what we refer to as a Vent-Tech style fan. It may not be that brand, but it's just an inline fan that moves typically in the neighborhood of 350 CFM. That stack underneath it is a filter stack. Expanded media, high efficiency filters, able to pull out a lot of particulate. They're typically charcoal impregnated filters, or at least one layer of that filter is charcoal impregnated with activated charcoal. Activated charcoal is there to remove odors. Odors are chemicals, really. Almost all odors are chemical related. So activated charcoal is the primary medium to remove chemical odors, chemicals from the air. They also will remove VOCs from the air. And then there's a pre-filter wrapped around that. Now those are key here because I'm going to get into the fact that where the codes require ventilation, this is not your typical installation. They try to artificially enhance these environments so that the plants can grow most efficiently. And that will include the introduction of CO2 gas to enhance this environment so the plants reach optimum yield. And that also, my understanding, affects the content of the product as well. So we'll talk more about this whole theory on, why we have to filter out the contaminants in these spaces, and relative to energy usage, relative to this artificially efficient environment that's almost like it's an industrial process. So what is a marijuana grow operation grow house? Here's another component in the back. You'll see,
Hey, Ken,
looks like an ordinary house fan. Yeah,
I'm sorry. I got a question.
yeah,
Can you go back to that previous slide?
sure.
Now that fan right there with that charcoal filter, all that's basically doing is mitigating the odor. It's not bringing in any fresh ventilation outside air, correct?
Correct.
So its only purpose is to mitigate the odor. But do I got ventilation air coming into that little grow place there? It's a little place. It's not a big grow.
This one, from my observations of what I can see, I do not see ventilation air. Actually, this would be very typical. And that's a good question. I'm glad you bring it up. And this is really keystone to trying to what I want to say, meld the code requirements with the requirements of the facility. The codes are very prescriptive, as Neil's alluding to here, on ventilation air. Unfortunately, the tables in the Michigan Mechanical Code or International Mechanical Code do not address a grow facility and the amount of ventilation air required for such facility.
Now, Ken, in the city of Detroit, we promulgated a city ordinance that requires a certain amount of ventilation air based on the size of the facility and the number of people that will be there. It's a city ordinance requirement. So if that was in the city, it would fail for no ventilation air.
Okay. You recall what that rate was off the top of your head?
I have it somewhere. I do not recall the exact one, so I don't want to give you the wrong numbers.
Okay. Well, and I'm familiar with a couple other municipalities that have a actual air movement requirement, but it's based on filtration. Because the particular ordinance, and actually that ordinance is pretty widespread to my knowledge, that ordinance addresses the filtration for the odor and the chemical removal and other contaminant removal. And the reason whoever did that had a fair amount of foresight, because we can examine the mechanical code, and there is a provision in there, and if we get time, we'll look that particular code section up. But in chapter 4 and chapter 5, in the general section, this will be the first portion of those two chapters, it talks about removal of contaminants by virtue of exhaust. And then, of course, with exhaust, you would always have makeup air, correct?
You have
Well,
to,
what happens is there is a provision in there that's called a separate removal system. And the removal talks about not removal of air, it talks about removal of contaminants. So in a lot of cases, the AHJ will approve these as an equivalent and meeting the requirements of a separate removal system. And the code actually has that language in there to allow that in lieu of exhaust air. It took me several years to actually realize that that was the case. Originally, I don't know how long that code provision has been there, but there was a lot of resistance to this originally because it requires human intervention. Because if that filter is not maintained, obviously, then we're no longer removing contaminants. But then again, the same thing with an exhaust fan. If the exhaust fan is not maintained, we're either removing the exhaust at a lesser rate than what's required, or if the louvers get plugged with dust and dirt, same thing. We're reducing the airflow rate. So almost everything requires a certain amount of human intervention to maintain it in its originally designed condition. These places are highly regulated compared to other businesses, so I would think that the periodic inspections that are supposed to be performed by the state of Michigan licensing authority, whoever they delegate that authority to, and the local fire inspectors.
and the numbers
Great.
for the ventilation for the city of Detroit, I got it right here. And they want 0.12 CFM times the square footage of the facility. Plus, they're designating one person per 300 square foot of facility, and they want 20 CFMs per person.
That sounds in line with what the tables in 403 call for for similar occupancies. I would say, that probably, maybe in the range to take care of the odors, although I'm not an engineer. I imagine they came up with that, through some scientific basis or some other standard they're referring to, pulled that information from. But what's going to happen is they're still going to need to remove the odor. From my understanding, the act itself has a provision in there that, and the mechanical code generally is, hey, we cannot discharge noxious odors and fumes that will affect our neighbors. Although the mechanical code gets very prescriptive on the distance from property lines or lines that can later be built upon. So, I don't know if the facilities you're talking about are still having a, charcoal filter set up to remove odors before this air is discharged to the outdoors. In how the state's looking at that, I can't answer that part, but. So back to here, I was going to point to, in the very back, you'll see these little towers. Those are one of the major vendors for that is, I think, like a company called Iponics, but they're all quite similar. It's just automated watering and fertilizer for these plants. Now that controller that's in the middle there also controls usually the CO2 discharge, will control the lighting, all of those types of things. And it also will control this fan here. And usually you'll see multiple fans like this. These fans are meant to have air turbulence in the space to stir this air up. When you're stirring that air up, it does something to the growth of the plants as far as making the stalks sturdier and healthier. Because they're packed so densely, they could get mold or fungal growth. So if that air is not moving a lot in there, it creates a problem with the plants. So, but the plants like to sleep. So they not only sleep by the lighting cycles, but they also sleep by the fertilization, watering, and this air movement cycle. So there are many smaller spaces with even smaller compartments. Some growers like to do this to eliminate a widespread crop failure. If they get mites or mold or fungus growth, they can lose millions of dollars if it goes through the whole space. So you're finding that some of them will break these up. Now, I don't know what they have on the walls in this particular location. I can't say for sure, but from a building inspection standpoint, the wall coverings need to make sure, we need to make sure that they're in compliance with flame and smoke ratings from a building inspector standpoint. And they like to get creative as to what they put on the walls. They want something smooth, easily cleanable. In this case, it looks like it's almost a form of insulation with the vapor barrier on it. Vapor barrier probably is a good idea because these are humid areas. Maybe would prevent moisture traveling into the construction of the building. But if it's not flame and smoke rated, it becomes a huge fire hazard for the building and any occupants that may be in there. And they like to say these are unoccupied spaces, but they're really not, because periodically requires a lot of care and maintenance. There's people in there maintaining the plants, making observations, taking notes on growth, inspecting the lighting, making sure the bulbs, don't need changed. In the case of the charcoal filters, changing out filters. It's a lot of maintenance. And then maintenance with the crops too, not just the equipment. So here we're looking at some different methods of introducing CO2 into the environment. So we're artificially enriching the environment with CO2 known as carbon dioxide. I don't want people to get that confused with carbon monoxide. They both kill people. They both kill people very quickly in the right concentration, quickly as 30 seconds. The only thing is CO is carbon monoxide that would maybe come from a furnace or a vehicle exhaust is known as the silent killer. Unfortunately, CO2, which is almost as deadly, is not called the silent killer, although we have had several deaths in this country, several debilitating injuries in this country from CO2 poisoning. Problem is CO2 poisoning mimics a heart attack. Upon autopsy, typically will be diagnosed as death by cardiovascular issues. That's because our body loves carbon dioxide. Our body loves carbon monoxide. They're naturally occurring in our bodies. Therefore, the blood loves to absorb these things. Matter of fact, the blood absorbs these things about 10 times faster than oxygen. So what we have here in the middle, this gray box with the, let's see, 1, 2, 3, 4, 5, 6, 7, 8, 10 different burner outlets on this burner. They call it a CO2 generator. You got to watch. The majority of these are unlisted equipment. Unlisted equipment can be very dangerous. The other thing is that it's really a rebranding or renaming of an item that we're all very familiar with called an unvented heater. Vents products of combustion into the space. So they are venting combustion products into the space for the purpose of enriching the CO2. The problem is combustion byproducts are not merely CO2, heat, water. They also produce NOx and CO. So carbon monoxide, the silent killer, and NOx is very highly toxic. And out of the box, they produce a certain ratio. So carbon monoxide may be lower, discharge may be lower when they pull this thing out of the box, install it on the first day. But every day thereafter, as these burners become dirty, get a little bit of dust on them, what happens is that the ratios become skewed from the original delivery, and they produce high ratios of carbon monoxide and NOx, especially if not properly cared for. Easily send people to the hospital, if not death. I'd like to take this moment to take a pause here and take a quick break, give you a 5-minute break. Okay, welcome back from break. Thank you. So we're on the subject of the what they like to call CO2 generators. We're tempted to call them unvented heaters, but I remember Neil and I having a discussion regarding equipment not required to be vented, which is a category of equipment, not a specific piece of equipment. And Neil, I guess you probably have that reference handy.
Yeah, I do. It's in the IFGC, International Fuel Gas Code 2015, section 501.8. And it says that aggregate input ratings of unvented appliances does not exceed 20 BTUs per cubic foot is allowed to be installed directly to the room.
Okay, and I'd like to add that is assumed. Pause here. That is assumed. Sorry about that. That is assumed that you would have normal ventilation rates in that space. So in areas that haven't conceded to normal outdoor fresh air rates, you know, they may be okay with that. But here's the problem. That says that unit comes brand new installed out of the box. And I really want to stress that, because if you've ever looked at an unvented heater after it's ran for even a week, they start to collect dust on them because they circulate air through there just by the convection process. That little bit of dust starts to turn that flame yellow. And now your ratio of carbon monoxide, carbon dioxide, and NOx produced are hugely altered from its originally installed condition. So these things require constant maintenance, constant checking. That doesn't mean that they do not need detection for the hazards that they present. And I want to back up again and stress they have to be listed equipment. There is a procedure in the International Fuel Gas Code that allows an HJ to approve unlisted equipment. Typically, it does not require them to approve unlisted equipment. It's just an avenue if they choose to do so. Really, it involves still pretty much testing, almost to the same degree as a listed and tested piece of equipment. It's very detailed and very well documented. Procedures have to take place. So is that all on the unvented heaters, or did somebody else have any other questions or comments?
Well, I just wanted to say one more thing. When you go to the same IFC section 621.1, it talks about it has to be tested and listed to ANSI Z21.11.2, and it's supposed to have oxygen depletion sensors on those. Does that 621 apply to that other section in 5?
Most definitely.
Okay.
Yep, you're right. And the unlisted ones will not have those depletion sensors normally, the ones I've seen. Things change every day, though. People come out with new products. I'm aware that there was one listed device that I have been told that was out there called a CO2 generator, but it does fall into the category at which Neil described in the IFC, International Fuel Gas Code, as appliances not required to be vented.
And Neil, when you approve that in the field, it still needs a listing, you know, unless it doesn't, you know, according to that code. Do you also then review the manufacturer's instructions? I mean, most of those will say installed according to those instructions. And do those possibly ever have any ventilation rates included or anything like that?
On the installation instructions?
Yeah. I mean, how much can you get out of installation instructions for something like that? You know, an unvented appliance just, you know, that just goes contrary to everything that we've been taught over the years.
Well, here's the thing. Engineering wise, it doesn't make sense, because these guys spend an astronomical amount of money for their heating and cooling for these spaces. And I shouldn't say heating, cooling. They almost never need winter heating unless it's actually like more like a greenhouse. But if it's an indoor facility for cultivation, and I don't care if you're cultivating lavender or production of essential oils or marijuana or what it is, it's all the same process. So what happens is, yes, introducing these contaminants into the air can still be a problem. And that's what, when we do a hazard review, we'll review this and we'll point this out and try to vet this out ahead of time. The majority of people want to install these so-called CO2 generators. They are unlisted equipment. And as soon as we start pointing out the fact that it's going to require you to provide an additional cooling capacity, an additional dehumidification capacity. So you're dumping heat into the space to go and remove heat from the space. It doesn't make a lot of sense.
Mm-hmm.
And once this is pointed out to them,
Uh,
the majority will change anyways, because they're unlisted equipment typically. And then when they find out the additional BTU load that's required for both the moisture and the, the latent and the sensible heat, they rethink it, and then they wind up going to a bottle or a bulk tank system.
and Ken, just to back up what you're saying about that ventilation air still required, taking into consideration, if you go to the IFGC section 630, infrared radiant heaters, which are unvented heaters, in 630.3, combustion and ventilation air, where unvented infrared heaters are installed, natural or mechanical means shall provide outdoor ventilation air at a rate of not less than 4 CFMs per 1,000 BTUs. So there in that section, which is still an unvented heater, infrared radiant heater, they're prescriptively saying how much ventilation air you need for those unvented heaters, to where those other ones, the manufacturer might not even have it. There's a lot of requirements in the code that if you go to read the installation instructions are not there. Or they'll say, per authority having jurisdiction, the installation requirements. So the installation instructions don't give you the whole gist for the safety installation. You still got to go.
Well,
Yep.
yeah, I agree. You have to take the most stringent, obviously, and you have to follow the code minimum. The only place you can't follow the code minimum is when the code directly conflicts with the listing of a piece of equipment and makes that equipment operation unsafe, which you're not going to find in this application. But so yeah, it's typically the most stringent shall govern when you weed your way through the code hierarchy. The ones that are the most deficient in their instructions are the unlisted ones, which I have not approved to date anyways. Marijuana growing, processing, or extraction facilities. The I codes are starting to catch up with NFPA, and currently, for those of you who aren't aware, I'm involved with the Fire Code Action Committee. I am not a Fire Code Action Committee member. I am an interested party. I participate in those actively. Further, I've been accepted into 4 different work groups, one being 3D printing, the other being distilleries, the other being indoor cultivation and extraction and related processes, which is going to be in the new International Fire Code 2024 edition. It's going to be, that's the edition we're working on. That's going to be titled, or it's going to be chapter 39, I believe, in the International Fire Code. We're fixing a lot of these problems with the code that we talked about. The unvented heaters, that's going to be fixed. Or equipment not required to be vented, is what I should say. It's going to be taken care of. And the threshold that you're talking about, Craig, at least on the marijuana side of things, or the indoor cultivation side of things, is going to be taken care of too. At least that's our intent. If these go through in the code hearings, we'll be all set. And the other one I'm involved in is hazardous materials. So we have every 2 weeks we have meetings on all these groups. right here, I just want to stress this, and this is typical throughout your codes. See 38.14 right here? Can you see my cursor? You see that highlighted section?
Yeah, you got blurry again though, Ken.
The whole thing?
Well, I think every time you do something, it's you lose some bandwidth. If you let it set, then it comes up, but
Okay. Can you read it now?
not quite.
I'll read it. 38.14 of the 2018 edition of NFPA 1, which is the NFPA's version of the fire code. This is referred to by the LARA laws and the LARA rules, both, for marijuana facilities. Where material or its use or associated processes pose multiple hazards, all hazards shall be addressed in accordance with applicable requirements of this code. Then we go back to intent and matters not provided for that are both in the mechanical code and the IFC in the intent of the Michigan Building Code as well. So those have to be met. And that's how we can deal with those situations that arbitrary threshold of the 100 pounds that's in the code is sometimes still a hazard. We have the ability to still, and we have the obligation to still deal with that.
That's good to know.
I've had numerous discussions with ICC on the using the intent to get places, especially on matters not provided for. If there is a documented hazard, a known hazard, we not only have the right to deal with it, we have the duty to deal with it. It's part of our mandate. So now 38, just the thing I want to point out, there's a lot of highlighted sections here, and I know it's blurry, you can't read it. But the key thing is there's numerous references to other codes, other standards, other chapters, other code sections. There's over 60 different references just in this one chapter that refer you out of this chapter to other codes and sections. I'm going to go to, because one of the sections it refers you to is for the specific materials and specific hazards you're dealing with. So we have very similar in NFPA 1 is very similar to the IFC in most places. NFPA 1 is a little more detailed because that's a 2018 edition, where in the IFC we're only on the 2015. And to date, I have not witnessed or seen the listed one that is claimed to be out there myself. I've heard about it, is all. But you're right. And so people are going to argue, because you're talking about infrared heater and it gives a prescribed mechanical ventilation rate to provide adequate combustion air for this unit, for an infrared unit. This is really no different. So you can go back to two things to enforce this. One is when we were talking about our tools, we mentioned scope, but there's the most important tool of all, and I don't know if I even touched on it yet, was the intent. So the intent is to provide for the safety of the occupants, first responders, and firefighters, health, safety, and welfare. If it is determined by the code official that the intent is not met, then you can enforce whatever is necessary to to ensure that the installation meets the intent of the code.
And Ken, you've told
So
me.
there's a documented hazard to discharge those products of combustion into a space that has inadequate ventilation air. You have every right to ask for what's required to meet the intent of the code. This is numerous discussions with ICC on this matter, on interpretive issues relative to the intent of the code.